Couldn't be here today, but Ms. Stein's going to help you through these problems. Just wanted to let you take some notes first. Today what we're going to be doing in class is in Chapter 6.4, and we call these and problems. And the reason why we call them and problems is they're going to deal with it where in life we don't just need one thing, we need something else to happen. So here's a sentence you might hear about in English. I want Gabe to be quiet and I want him to get an A. So the key word there is and. So if he's quiet but doesn't get an A, that's not good. Both things need to happen. So when in math, when you hear the and sign or you see that there's an and in there, you know that both things are going to have to happen at the same time in order for the solution to be true. So for example, if x has to be greater than 9 and x has to be greater than 12, would a 10 work? Well, let's see. Does it satisfy both conditions? Sure, it's greater than 9, but is 10 also greater than 12? No. So therefore, the 10 wouldn't work. But a 13 would work, a 14 would work, a 13 and 5/10. All these things would work because they satisfy both conditions because there's an and sign. Now, we call this a conjunction. It's just a fancy way of dealing with these and problems. It's when you use the word and. In English, we call that a conjunction. And again, we've talked about both conditions need to be met. This is also referred to, so some math teachers might call this an intersection problem. And again, a lot of other teachers call them and problems. And this right here, this little upside down U, you'll see in geometry, that is pretty much the same thing as saying and. This is a conjunction sign. So you know that both things, you need the intersection of both things. In algebra, you're really not going to see this as much as you will in geometry. All right, so first thing we have to know is how to graph conjunctions or and problems. So here's the first problem. X is greater than 4 and x is less than or equal to 20. So we basically have to show on a number line the things that are greater than 4. So a lot of times below, I kind of maybe do a little rough sketch. So greater than 4 would be an open circle on 4 and forever this way. Less than or equal to 20 would be a closed circle because it can be 20. And then it's going to go this way forever. So where do both things happen at once? Well, when you make a chart, you could kind of see where are there both lines. There are both lines happening right here, 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 and even here right on the 20. Because 20 is not only greater than 4, but it's less than or equal to 20. So that would work. You can see that not only do I see a line, but I see a closed circle. So your final answer is just going to be the intersection of where they both happen. So this is just, you wouldn't really include this on your paper. That's just to help you know the answer. So the answer would be an open circle on 4. It'd be everything between 4 and 20, including the 20, but not including the 4. And this right here is very, very important to write down because with conjunction or and problems, sometimes you'll see the word and, but other times you'll see it written like this. And what this means right here, essentially the thing in the middle, if you have two less than signs, they could be less than signs or they can be less than or equal to signs. But as long as you go from least to greatest, you notice the 4 is smaller than the 20. This means that x is between 4 and 20, including the 20. So if I wanted to say, for example, that x is between -4 and 12, I'd write a -4, less than sign x, because that's the number we're dealing with. I think I said 12. So this would just simply mean that x is between -4 and 12. And again, if you wanted to write it the first way, instead of saying -4 is less than 12, you could say that means that x is greater than -4 and x is less than 12. So, finally, I'll say this again. These two things are saying the exact same thing. So next. Okay, next what we're going to do is just to graph another one. This is kind of like the one in front. It's x is greater than or equal to 7. So that would be all this stuff. And x is greater than 12, which would be, well, not really a 12, but it would be the stuff greater than a 12. So where do we see both things at once? Well, right here. So when you see the and sign, when do they both happen at once? Well, they don't really happen at 12 because this one doesn't happen. This one, 12 isn't a solution here, greater than 12. But the solution would be all this. And in this case, you don't have to even use the and sign. If I wanted to just put one answer, x is going to be anything greater than 12. It's because they really only happen when it's greater than 12. Though a lot of times you'll see with and problems that it'll be the in-between two things. And you'll see that in a second. So that's how to graph it. Again, you could pause the video and graph these two things for me to make sure that you know how to do it. Go ahead and pause it, but I'm just going to keep working. So when you're done, you could replay it. This one, x is greater than 8 and x is less than -2. This one would actually have no answer. Because the stuff that's, if right here is a -2 and right here is an 8, the stuff that's less than -2 would be all this stuff. The stuff that's greater than 8 would be, open circle, this stuff. Do they ever actually intersect? Do they both happen at the same time? They don't. So this would have no solution. There is no answer to that one. In this one, x is less than 4 and x is greater than or equal to 1. Well, we put a 1 there, and it's going to be anything equal to or greater than 1. And then you have less than 4. So 4 would be right here. So you have an open circle going this way. So where do they intersect? Well, it's going to be the things between these two guys. You see that right there? You see those two lines? So the answer would be between 1 and 4. But 4, it doesn't include the 4, but it's going to include the 1. And you can write this. We talked about this before. We could pretty much say that x is between and including. We write the smaller number there and the bigger number there. And this would be your final answer. And again, all this is saying is a fancy way of saying this. All right. Now, we get into the solving intersection problems. Now, how do I know it's an and problem? There's two ways. One, it's going to have those two less than signs. See, we talked about this before. So this means that this x minus 4 is between two things. Or it's actually going to use the word and. So if it uses the word and, duh, it's an and problem. Or if it's set up like this with the two less than signs and the variables in the middle. So it's very easy to solve. This is what we call a compound inequality. And it's called a compound inequality because there's two things happening at once. You just don't need x minus 4. You know, if you cover up if you take this and you cover up half the problem, it's two inequalities. You have x minus 4 is less than 2, but then you have another inequality. You have -5 is less than x minus 4. So again, when there's two inequality signs, that's why we call it a compound inequality. So to solve this, you basically set up two inequalities. We're going to put the thing in the middle twice because x minus 4, you're saying two things about x minus 4. At one point, you're saying it's less than 2, so I just took that first part. And the other time, you're saying -5 is less than x minus 4. So we're going to solve them separately. Plus 4, plus 4. You get x is less than 6. And over here, you're going to add 4 to both sides. And you get -1 is less than x. Remember, we talked about we always want the x on the left. So we're going to flip-flop them and then switch the sign. And now I have my answer. But I'm going to put, remember, because this was set up the original way, this compound inequality is an and problem. So I'm going to use the word and. So I'm just going to now read my answer and think about what it means. X is a number that's less than 6, but also x is a number that's greater than -1. So if you were to graph that, it would look like this. Numbers that are greater than -1, but also numbers that are less than 6. Notice I have two open circles. Well, this right here, I would give full credit because this is the answer. And this is definitely the right graph. But one thing I want you to get in the habit of doing is rewriting this so that you can say it, it's just a lot easier to talk about x being between two things. So again, you put the smaller number, the less than sign, the x, because it's not, you would put an equal sign if it was equal to -1. Put another less than sign, 6. And this is saying that x is between -1 and 6. Let me show you one more. Now, this problem's a little bit easier because it actually shows you the word and it has already separated the two problems. If you have the word and, then you don't really have to do much but solve each one. 3c is less than 12. I divide both sides by 3, and I get c is less than 4. Make sure, remember, if we divide or multiply by a negative number, we still have to use our rules of inequalities and make sure we flip the sign. Add 4 to both sides on this one. You get 2c is greater than negative 2. I divide both sides by 2, and I get c is greater than negative 1. Notice I didn't flip the sign because I didn't divide by a negative. I divided by a positive 2. So, and then we're going to write our word, it's an and problem, so we're going to keep the word and. So here's our answer. C is greater than negative 1 and C is less than 4. Then we're going to go ahead and graph it. Less than 4, but greater than negative 1. And then we can go ahead and write it a little more clear and say, instead of writing this, I can say that, well, really, C is between, but not including, negative 1 and 4. Let's see if there's one more to do. So this is a b right here. I'm going to make it capital. So negative 6 is less than b minus 4. I notice it's a compound inequality because there are two inequality signs. And remember, this in the middle, b minus 4, is a number that's really going to be between negative 6 and 2. So let's see. Now, again, I know it's an and problem because there's two less than. Negative 6 is less than b minus 4. And, I'm going to write and. B minus 4 is less than both of them. B is less than 6 and 4 on both sides. Negative 2 is less than b, but remember we want our b on the left, so let's switch the number and the variable and let's flip the sign. And there is my answer. B is a number that's greater than negative 2. And remember, had this been a, we're going to, for this problem, let's go ahead and change that so you could see another one graphed. So we're going to say b is greater than or equal to negative 2 and b is less than 6. So it's greater than or equal to negative 2, and it's always going to be less than 6, so that's an open circle. And now I can say either this or b is going to be between, but including the negative 2, but less than 6. B is between negative 2 and 6, but including a negative 2. All right, so that's how you solve problems like that.